Okay, in a previous exercise, we added a pump to the network. Now, one of the interesting properties of a pump, as opposed to all the other elements that we have thus far added, is that the pump need energy to operate. So, a whole host of questions arise. Okay, what is the efficiency of the pump? How much energy does it use at a given time or during a whole day? And what will be the energy cost. So that is what we are going to address in this video. Now, if you look at the properties of a pump, you can see that there is an entry called power. Now, this is the most rudimentary way of uh, providing power details to the model. That is, if we don't have any pump curve information, then we can provide the constant power to the pump, uh, some sort of wattage rating, and that will be used to calculate the costs and things like that. But generally, um, manufacturers of pumps, this is an example from a pump manufacturer called KSB. Let me uh, zoom it a little bit. Yeah, so it's a bit of a busy graph, but what you will see here is this is the x-axis is the flow, y-axis is the head, and these are different pump curves of the pumps they provide. Actually, this is about different pump impeller diameters. Let's take this bottommost curve uh, and try to understand what is going on here. So, uh, when we provided the pump curve to EPANET, what we did was to try to mimic this thick black line. Now, if you have a manufacturer's catalog like this, then we don't do it just by providing a single point, but what we can do is we can sort of digitize this curve. That means pick up some coordinates here and there, like different Q and H values, and provide that to EPANET, and EPANET will construct this pump curve exactly as it is. Now, there is another set of numbers here. These 36.4, 35, 30, 25, those numbers. These are actually the efficiency numbers. So depending on the position at which the pump is operating, because pump operation always shifts around this curve, depending on the location where it is operating, it will have different levels of efficiency. That is what these numbers say. Okay, going back to EPANET. Now, let's try to add some uh, power and efficiency details to this pump. I will also give a better name to this pump. Pump ID now is 4. We'll call it P for pump 4. Yeah. Of course, we have one pump, but I just give it the name pump 4. Now, go to curves and have a look at your pump curve. So this is the curve I was talking about, showing that manufacturer's curve. So if you digitize values from manufacturer's curves, you can give number of values here, and EPANET will take them and construct the pump curve exactly as in the catalog. But for the moment, let's not bother about it. Remember these two numbers, 20 and 45. That's the central part of the curve. Typically, this is where the uh, pump is mostly of highest efficiency. Okay, so now let's go ahead and add an extra curve. Sorry, I have accidentally added an unnecessary curve here. Let's delete that. Okay, extra curve. Now this time we are adding an efficiency curve. Yeah, we'll call it um, EF1. So when the flow is, let's say 20, we assume, well, you have to get this from a manufacturer's catalog, but for the moment, bear with me. This is 50%. When it is 10, it's 35%. When it is 30, it's also 35%. Yeah. When it is 2, let's say it's 20 or 15%. When it is 40, let's say it's also 15%. So this is a, now we have efficiency curve for the pump. Now we can go back to our pump and assign this efficiency curve here, EF1, right. Now let's also go to options, energy options, double click, energy price. Now for this case, well, let's use any of the local currencies. Let's say the energy price is 5 rupiah per kilowatt hour commercial rate. You can also add the price pattern, that is um, you can see it here, that is if the energy price changes with time. In some countries that happens. In the night it's cheaper than the daytime, but well, let's not go there for the moment, right? So now we can try to run this model. It's successful. So I'm not going to focus anything on the hydraulics at the moment because that's we have covered that. But if you go to uh, report, energy report, yes, you can see that now the pump has been utilized for 100% of the time. The average efficiency of the pump is 41.57, depending on where in the curve at each hour the pump is operating. Yeah, kilowatt hours used per cubic meter of water, average kilowatts used by the pump, peak kilowatts, the most energy the pump has used, and then the cost per day. So these are useful information, especially if you are dealing with the energy situation of a network. This information is useful. Okay, that is it for this video. Thank you.